we are getting into our last little portion for volume. It's a really, really quick ending of the unit because it's a pretty easy concept with volume. Find area multiplied by height. Find area multiplied by height. Sometimes you're going to have to work backwards, like questions like this. You guys had some questions on the scavenger hunt that you guys came up a couple of times and asked, what do I do if they gave me the volume and I have to find a missing measurement? That's similar to what these ones are. And I want you to be aware that you do have some test questions like this. So you might want to make note that on here, if you understand how to work backwards, it's similar to what a test question would be like. So when they're giving you the volume, they're telling you the volume already ahead of time. Remember, volume is found by doing the area of our base shape and multiplying it by the height. That's what big B stands for, right? Big B stands for the area of our base shape. So the only thing that changes in your volume formula is whatever this area is going to be, right? If it's a rectangular prism, then this part of the formula is length times width. If it's a triangular prism, then this part of the formula is base times height divided by 2. If it's a cylinder, then this part of the formula is r squared times pi. So this is always going to be changing. This little portion right here is going to be the only thing that you manipulate depending on the shape. So this is your area, and then this right here is the height of the actual prism, what connects those two areas together. So that is a constant. When we're looking here, thank you. You want to teach? Okay, then shush. All right. I'm kidding. I know you're very, very smart, and I'm very happy that you got it. I also know that you got this one correct, too, because I heard you saying it. So congratulations. All right. We know that the formula for volume, because we are dealing with a cylinder, we know that we're dealing with the formula r squared times pi for that area portion, and then we're going to multiply it by the overall height. So here's where the overall height is. However, we don't know that value. That value is an unknown. The only thing that we do know is this value right here, which again, that is called our diameter. That's our diameter's measurement. So we know D is going to be equal to 10. So what does that make R? 5, right? R is going to be 5 because we have to divide the diameter by 2 to get the radius. So then we can substitute what we do know into the formula that we have here. We do know the volume. We know the volume is 1,884. We do know the radius. That's a 5, so we can put 5 squared. We also know pi. Pi is 3.14. So the only measurement that is an unknown is the value of our height. Okay, so then like I said before, all the time whenever you guys are working out equations, you just do what you can do before you start solving. So what is something that I can do right now? Something that it's telling me to do, I can actually do it because I see the numbers there. What can I do? Go ahead, Maria. Yeah, I can multiply 5 squared times 3.14 because those are numbers. I know how to multiply plain numbers. When I do that, I get 78.5. So now I have 1,884 is equal to 78.5 H. Okay, that's just an equation then. What's the inverse operation that I have to do to this equation? Go ahead, Yomar. Division, right? We just have to go ahead and divide. So we're going to divide both sides by 78.5, and that's going to get the height isolated, which, as Yomar had already told us, is 24. The height will be 24. Okay, same thing for this one. Again, we know that the volume is going to be equal to 1,884. But this time we don't know what R is. So we're going to leave it as R squared. That's what our question mark is. We have no idea what the radius is, but we do know pi is 3.14, and in this case, we do know the height. The height is going to be 6. So again, we do have parts that we can work out first. We can multiply the 3.14 and the 6. We can actually multiply those together. So as we're simplifying, we get 1,884 is equal to r squared times 18.84. And then just like we did with the previous problem, we want to get the variable by itself, so we're just going to go ahead and divide. We're going to divide both sides by 18.84. And that's going to leave us with the value 100 is equal to r squared. But I don't want r squared, I want r. So I'm going to show you guys what the inverse operation is for exponents, because we do have inverse operations of exponents. So just like inverse of multiplication is what? What's the opposite of multiplying? Division. What's the opposite of subtraction? Addition. So there's actually an opposite or an inverse to your exponents. Okay? If you have an exponent or a power of 2, the inverse operation is called a root. It's a square root. So if you look at your calculators, so I'm going to cover this up for just a second so you guys can see it. Okay, on a calculator, in order to get a square root button, you first have to hit this green button the second. And that means everything that's now in green is what the button becomes. And if you look right here off to the left side where you see x to the power of 2, right above it in green is your square root button. So when you tap that, you get your square root symbol there. And then you can just type in, hey, I want to take the square root of 100, and then you'd hit enter and you get 10. Okay? So you can also do non-square roots. You can do cubed roots or fourth roots. In order to do a different root besides a square, the button right above our square root button, so that up arrow, if you hit that up arrow, it becomes an exponent. If you hit the up arrow, that becomes an exponent. But if you hit the second button and then the up arrow, oops, I hit the wrong one. Second button and then that up arrow, then it starts to give you a value where you can say, hey, I want to take whatever number I give it as a root. So let's say I wanted to make it a third root. I could type 3. I could hit second, and then I can hit that up arrow, which now makes this a cubed root. I can do it for 4, hit second, hit that up arrow, and it's now a fourth root. So anytime that you have an exponent that you need to undo, you can undo it by doing a root. Okay? Now the only ones that you're going to be focusing on are going to be square roots for this year. So the inverse operation of a squared value is a square root, which is the second and then that button right here in green. Right, so again, if we take the square root of both sides, I take the square root of 100, I take the square root of r squared, then that's going to leave me with the value where r is equal to 10. Which we all know because 10 times 10 is 100. All right, so what we're going to be finishing off for today is our composite figures. So how a composite figure works is you are taking the volume of each separate shape and then combining them together by either adding them, if it's something like what number 2 and number 3 look like, or if you're looking at like problem 4 on the back of your paper, this would be a subtraction one because you're drilling a hole through it. If you're drilling a hole, you're removing something out of the block. So like number 4 would be a subtraction problem, 5 and 6 would be addition problems. So composite figures are either adding volumes or subtracting volumes together, okay? So if we're taking a look, we have to look at each shape individually. Who can tell me what is one of the prisms we have here? There's 2 different prisms. What's one prism you guys see? Amina? Triangular prism. We have a triangular prism right up top. And then what else do we have? What other prism do we have, Maria? A rectangular prism. So we have a triangular prism and we have a rectangular prism. So what we're going to do is we're going to find the volume of our rectangular prism. And then we're going to find the volume of our triangular prism. And then we're going to add those volumes together. That's all we're going to do. Find the volume of both prisms and then add the volumes together. So for here, again, like I said, the formula is always going to be the area of your base shape multiplied by the height, plus the area of this base shape multiplied by this one's height. Okay, so let's first focus on the volume of the rectangular prism. Which one of these measurements is going to, or which two measurements do you want to use as the area of the base shape here? The length and the width of the rectangle. Which one do you want to use? Look at your rectangular prism. Identify your base shape. Michaela? 6 and 20? All right, sounds perfect. So she's focusing on the bottom rectangle. She's letting that be her base. So she's going to use the 6 and the 20 to find her area. Remember, area for a rectangular prism is length times width. So we're going to do 6 times 20. And 6 times 20 is going to be 120. Okay, that means what value has to be the height of the rectangular prism? 10, right? 10 has to be the height for the rectangular prism. So we're going to multiply this all by 10. So when we do 120 and we multiply it by 10, that gives us a volume of 1,200 for the rectangular prism. Now we're going to do the same thing again for the triangular prism. With our triangular prism, that formula is going to be base times the height and then divide it by 2. Base times height divided by 2. So what's the base of the triangle? So let's identify where our base of our triangle is located. Here's my base of my triangle. What measurement is that? 6. Okay, now the height of my triangle. Here's where the height of my triangle is. What is that? 4. So 6 times 4 divided by 2. Okay, and then we're going to multiply this by the height of the triangular prism. So what is the measurement that takes us from this front triangle to this back triangle? 20, right? Yeah. Good. So we're going to multiply that by 20. Once we do that, we're going to get 240. And then all you have to do is add those two measurements together. So our final volume is 1,440 centimeters cubed. So again, all you are doing is finding the volume of each of the individual prisms, and then in this case, you're going to add those volumes together. So pretend like each of the shapes are separated, focus on them one at a time, and then combine them together. What you guys are going to do is you're going to work with your groups on problems 3 through 6. You guys are going to work together on problems 3 through 6. Tomorrow, we'll go over the answers. So do not lose this paper. This is your notes. Do not lose it.